the Upstart configuration files, Part 1. If you're looking for an etc/init tab in the Hardy Heron release, be prepared for a surprise. That file, which configured so much of the boot process, is no longer used. Upstart is the drop-in replacement for the init daemon, also known as the first process. Just about all of the directives formerly used in etc/init tab can now be found in a number of different files in the etc/event.d directory. In this video, I describe those files which replace the first few directives from init tab. But if all you've got is the Hardy Heron release, where do you get it in init tab? Well, it was available for the Dapper Drake release, and here's my version of etc/init tab from that release. The first line specifies the default run level. Run level 2 for the Upstart system. This is now configured with the rc-default configuration file in the etc/event.d directory. Let's take a brief look at that rc-default file. First, that run level --reboot command just records the time of the last boot. The first if conditional, which greps from proc/command line, looks for a single or an uppercase S in the kernel command line. If you've added a etc configuration file to your Hardy Heron release, the first elif or else if conditional parses the aforementioned line to look for a standard run level. If the default run level doesn't exist in etc/init tab, or that file doesn't exist, as it's missing from most Hardy Heron systems, the else conditionals take effect and the system teleinits to run level 2. For a bit of perspective, if you're more familiar with Red Hat-based distributions, you might expect a default run level of 3 or 5, depending on whether the GUI is installed. That's one way in which Debian-based distributions, including Ubuntu Linux, are different. But you should be aware, Red Hat distributions are also moving towards the Upstart system, so what you learn here will help you there. Now back to the etc/init tab configuration file. The second line, shown here, is now addressed by the RCS script in the etc/event.d directory. We take a brief look at that script. And we see that it executes the RCS script in the etc/init.d directory, and if you look at that script, you'll find that it executes all the scripts in the rcs.d directory. The line which follows in etc/init tab down here specifies what happens in single user mode. If you run the init or teleinit commands or boot directly into single user mode, you'll eventually get to the recovery menu, shown here. In another video, I discussed the other lines in the former etc/init tab configuration file and the replacements in the etc/event.d directory. The Upstart configuration files, Part 2. In another video, I have discussed the first few lines in the old etc/nittab configuration file and the replacement scripts in the etc/event.d directory. In this video, I discuss the last part of the former etc/nittab file and the replacement directives in the noted directory, and a bit more. To review, I take the etc/nittab that I'm reviewing from the one used, at least on my system, for the Dapper Drake release 6.06 of Ubuntu Linux. About halfway into the file, which I've highlighted here, we have a series of comments along with run levels. As suggested by the comments, run level 0 halts the system. Run level 6 reboots the system. Whatever the default run level is, as defined by the first line, determines which of these lines down here are run between 0 and 6. These lines in the etc/event.d directory are replaced by the rc0 through rc6 scripts. For example, if run level 0 for some reason happens to be your default, that runs the scripts in the etc/rc0.d directory. For most cases, the default is run level 2. In that case, the rc2 script runs these scripts in the etc/rc2.d directory. If there was ever a problem with a run level, the su login script sort of acts like an emergency script. In the Upstart system, that's replaced by the su login script, as shown here. Back to the nittab configuration file. When the Control-Alt key combination is pressed, it provides a CA signal, and in these run levels 1, 2, 3, 4, and 5, this particular shutdown command is run. That's been replaced with the Control-Alt-Delete script, which runs a slightly different shutdown command. The -R actually reboots the system. One thing no longer addressed by the Upstart system, or isn't addressed by the Upstart system, are power failure messages. These messages, PF, PN, and PO, are signals generally sent from an uninterruptible power supply, also known as a UPS. If you have a UPS on your system and it's connected, you should install the powstat-d package. The files in that package include its own scripts which replace the messages shown here from etc/nittab. The final active commands from etc/nittab are associated with geddies. Geddies are essentially command line terminals. I've logged into TTY1 to show you a nittab. This is in TTY2, and as shown on top here, I haven't logged into TTY3, 4, 5, or 6. The first Getty is started in run levels 2, 3, 4, and 5. The other Gettys are started in run levels 2 or 3. As suggested by the comments, you can add even more Gettys if desired. You can access these different Gettys by pressing the Alt key simultaneously with the function key associated with the Getty. In other words, Alt F1 gets you into the first Getty, Alt F2 gets you into the second Getty, and so on. In most cases, Gettys are automatically respawned. What that means is when someone logs off, say in virtual terminal or Getty number 3, that Getty is automatically respawned. Alternatively, if you've killed the process associated with that Getty is also respawned. And that's the effect of the respawn message shown here. The functionality of these lines has been taken by the TTY scripts. TTY1 takes the functionality of the first Getty. And as you can see, it gets started in run levels 2, 3, 4, and 5. It's respawned, and so on. That's it for how the files of the Upstart system replace the directives in etc init tab. Upstart control with the init control command. There is another way to control the jobs in the etc/event.d directory. Yes, each of the scripts in this directory are jobs. These are standard processes which run on current Linux systems. To help control these jobs, the Upstart system provides the init control, start, stop, and status commands. First, let's learn a bit more about current jobs. What's currently running? This tells me everything. You might recognize every line in this list as files in the etc/event.d directory. So jobs are either waiting for input and are currently stopped, like the Control-Alt-Delete job, or they're currently running, such as the 6 basic Virtual Console terminals, TTY1 through TTY6. Now let's break this down a bit. First, let's see the status of a particular job. I've checked the status of the third Virtual Console, and it's running with the same process number as was shown in the output to the sudo init control list command. Now let's try stopping that job. We see a bunch of messages relating to stopping that particular job. And now the status tells me that the third Virtual Console is waiting. It looks like I have a console available, but I can't type anything in. You'll just have to trust me on that. Now let's try starting the job. I get a series of messages telling me that the process is starting. And look at that. I have the third Virtual Console active again on different lines. and now I can log into that console. For more information on the capabilities of the init control command, run init control help. There are several options available which I haven't covered but are beyond the scope of the curriculum. Now to end this video, let's try running the init control command to reboot the system. Init control start control alt delete. There we go. The reboot cycle is starting. We're ready for the next video. Configure and register a landscape client. If you don't currently have a landscape account, you can get one automatically. Just get a Canonical support subscription. You can apply for a 60-day trial. Just be aware they might say no. There are even special landscape subscriptions available. For more information, navigate to www.canonical.com/landscape/register. It forwards to the registration page, and follow the instructions. To get an Ubuntu client registered on a landscape account, there are some very specific instructions. Details are available within the landscape account. The first thing you need to do is update the client's etc/app/sources.list configuration file, which I've done here. As you can see at the bottom of the file, I've added the specified line for the Hardy Heron release to connect to the repository with landscape client packages. If you're using another release, such as Intrepid Ibex, substitute Intrepid for Hardy. Then you'll need to download the GPG or GNU Privacy Guard key and make it accessible. I've done so with the following commands, and as you can see, the result of the commands is that I've downloaded the GPG key and made it accessible to the apt commands. The result is OK. With the repository and GPG keys in place, I've run the sudo apt-get update command, which updates the package database from everything in the sources.list file, including the landscape repository just added. Once that database is updated, run the sudo apt-get or aptitude install landscape client command, which installs the landscape package and repositories, the final messages of which are shown here. Once the landscape client package is installed, I run the sudo landscape-config command to start the registration process. The script prompts for required information. You do want landscape to be started on boot, so the client can be monitored all through its lifetime. It continues with some descriptive messages. As the administrator, you should be able to approve the client once these steps are complete. You're prompted for a title, which will be the name in the landscape administrative interface. You might want something descriptive, such as the office number or administrative name. I've added a different kind of descriptive title. You're prompted for the account name created during the registration process. if you've set things up with a password, you'd enter the password at this time. But not all accounts specify a registration password. The steps you've entered, or the password you entered, pardon me, doesn't show on the screen. If there's a proxy server between the local network and the internet, you're prompted for that information as well. It could be a regular HTTP proxy or a secure HTTP proxy. If you don't have either, just leave both entries blank. You should configure script execution to allow scripts to be run from the landscape account. Of course, this requires users on the local system with appropriate administrative permissions. Once the process is complete, you're ready to request a new registration for the local system. Then you would have to go to your web-based landscape account management interface to confirm the registration. If you enter an invalid account, which I did to protect my own landscape account, you get an error message. And whatever you enter, just be warned, the information entered here is saved in clear text in the etc/landscape/client.conf configuration file. What does Landscape see of a client? Backing up a moment, Landscape is a proprietary interface. As of this writing, it isn't even open source. So the details I can show you is limited a bit, but the UCP curriculum requires you know something about Landscape's features and capabilities. And Canonical, which wants to sell Landscape, wants you to know what these capabilities are. Once you're logged into a Landscape account, assuming you have systems connected, you can review the current hardware inventory of every registered system. You can also review the current list of installed packages, also known as the software inventory. At least that's what it's called in the UCP curriculum. From the Landscape interface, you can review the resource usage of each system, including the load on the CPU, available RAM, swap space utilization, system temperature, as well as the space that's used on each configured partition. And this view of resource usage is available for every registered client. Landscape supports remote updates. In the same screen where you can request a security update or just a regular update, you have a view of Ubuntu security notices. How convenient! If you request an update, they're then delivered to your target systems the next time that system or systems are made available. Landscape can make things convenient for you. Once you've got a bunch of systems in Landscape, you can configure several systems as a group. That simplifies administration, as you can run single administration commands that are applied to every system in the target group. Landscape can also configure scripts to be run on individual systems. If you're familiar with the features of the Red Hat network, or SUSE's ZenWorks environment, you should already recognize some of these capabilities.